Yep.
Good stuff. Okay, listen, welcome everyone, and thanks for joining us today. My name's David Aaron. I'm the Marketing Manager for Graduate Apprenticeships here at Heriot-Watt. Today we're going to hear from Gillian Hughes from Techworks, and also Stu Edmondson, who's the CEO at UK Electronic Skills Foundation. And from Heriot-Watt, we also have Dr. Alan Faulkner-Jones and Dr. Adnan Elias, who are the programme leads for our EDM programme, brackets electronics. Just before I hand over to the first of our speakers, Gillian, I'm just going to cover off some quick housekeeping that you can see on your screen there. So we are recording the webinar today. I see everybody's been very well behaved so far, but I was just a quick reminder to switch off mics and cameras during the presentations. And once the presentations are done, we'll definitely have time for a bit of a Q&A, so you can either do that verbally or use the chat facility on the screen. So without really any further ado, I'm going to hand over to Gillian. You're first up. And Gillian, I'll drive the slide, so just let me know when you want to move on.
Just on you go. Thank you. Right, move on. Right, hi everyone. I'm Gillian. I'm here representing Techworks today. For those of you who don't know Techworks, basically it's a trade association, a member organisation which comprises of the different connected communities. My community is NMI, which we'll go into in a minute, which is the National Microelectronics Institute. We also have a community serving the automotive companies within the UK. We have Internet of Things Security Foundation, Power Electronics, and you'll hear from Stu later, who's the CEO of the UK Electronic Skills Foundation. Each community within Techworks serves a group of members' interests, whilst at the same time remains connected to the wider ecosystem, enabling cross-domain connections, and we all work in common challenges within the electronic sector and deep tech community in the UK. On you go, David. So initially NMI was formed in 1996 and it's developed to become Techworks. So it was initially formed to support the semiconductor industry in the UK and Ireland. You may be well aware of, we had Silicon Glen and the semiconductor industry was booming. So there was representation here, primarily in Scotland initially, to support that network. So as other communities were established, ASNP, UK and IOTSF, the Techworks brand was developed and NMI basically became under the umbrella of Techworks. So we remained a community and basically we all work together, crossing the full domain of Techworks now. 300 members. Now the members may range from 1 employee to 500 employees. So what we do is we get them to knowledge share, we encourage innovation, communication and collaboration between them all, look at the common challenges that they're seeing, common objectives and pull together. We do trade shows, events, that's primarily an events dominated organisation where we pull all these resources and people together. On you go, David. Have you skipped a slide there? Have I? Yeah. So, we're working in partnership with Heriot-Watt University to try and promote the new graduate apprenticeship programme to our members. I think we're all well aware that technology does change rapidly. I think we just need to look at the new disruptive technologies that operate on a daily basis. Name a few, IoT. There is a continuous need for new skills, especially within electronics and semiconductors. Engineers can't learn at the rate that the sector requires with innovation. It's quite difficult. So having been an apprentice myself many years ago, 30 years ago probably, I do see the benefit to organisations in having these apprenticeship programmes in place, not only to develop talent now, but also for the future. Within the semiconductor industry, which I'm primarily responsible for within Techworks, it's not a new problem. It's been a problem that's been ongoing, and Sue will probably touch on it a little bit more. and we need to actually, we will limit growth if new talent can't be found, and I think this apprenticeship programme is exactly what especially MAME need and are looking for. On you go, David. Done a recent survey where I looked at some of our manufacturing communities, and they did highlight the fact that the workforce, especially in the kind of technical sector, were 41 years old or over, and they were expecting to retire basically within the next 20 years, which isn't really good for the up and coming technology that we're seeing within the UK. So if you look at the apprenticeship programme that Heriot-Watt University are offering, I think it ticks a lot of boxes, for especially for my manufacturing facility. There are lots of recruitment problems, and I think this apprenticeship is basically going to fix that challenge that we're seeing going forward. So I will just pass you on to Stu, who will talk more in depth about the apprenticeship programme.
Thanks, Gillian. And as David said, I run the UK Electronic Skills Foundation, and I want to talk about graduate apprenticeships in Scotland as a precursor to the team from Heriot-Watt talking about their specific course. Next slide, please, David. We're a charitable foundation under the umbrella of Techworks, as Gillian said, and our broader aim is to encourage more young people to study electronics and pursue careers in the sector. And we work with a range of universities on undergraduates and connecting them with employers. We also done work on behalf of the electronic sector in terms of developing apprenticeship standards. There is a difference between apprenticeships in England and Scotland, and that's something we'll touch on in a moment. Why are we doing this? Next slide, please, David. And build, thank you. That's great. If you look at the industrial strategy and the Made Smarter review, all the challenges identified by the government as areas of growth, challenges and opportunities are all in technologies that depend upon electronics, be it in terms of challenges around the environment, in terms of decarbonisation, in terms of an ageing population. They are all dependent upon electronics. Next slide, please, David. And this is recognised by venture capitalists and investors. They are interested in biotechnology, the Internet of Things, AI as their big areas. And on the right-hand side, we all know that the massive investment in automotive companies and their supply chains in terms of connected, autonomous and clean vehicles. So there's a massive demand for future technology, which all depends upon engineers. If we look at Scotland, thank you, David. Make UK reported that electronics in Scotland contributes over 9% of GVA and around 8.7% of turnover. However, the demand for employable graduates is outstripping demand. If you look more broadly, build the slide. Thanks, David. If you look more broadly outside of electronics at the enabling sectors, which come under Technology Scotland, the photonics sector in Scotland is really next build. Thank you, David. Look at recent investment, 5G innovation. There's a lot of government support. So the sector, in a broader sense, the electronics sector is vibrant, is growing, contributes to the economy, but there's too few graduates. We know that 22% of employers have reported problems in recruiting engineering graduates, and they are designated as hard to fill appointments. So without some sort of intervention, this problem will only get worse. Next slide. Thank you, David. So one way, strategic way that governments are looking at tackling the graduate shortfall is to look at degree level apprenticeships. Let me just say, in England, apprenticeships are organised different from Scotland. In England, they're run by something called the Institute for Apprenticeship, and within engineering and manufacturing, there are 137 different apprenticeship standards that have been approved for delivery, of which 36 are at degree level, and there's one which is outlined on the left, which is to do with embedded electronic systems design and development engineer that we led the development of with employers who are based in England. And also on the right, there's a level 7, a postgraduate master's level apprenticeship just been improved for electronic systems. But that's England, where companies pay the apprenticeship levy. In Scotland, Next slide, please, David. The situation's different. Skills have devolved, and Scotland takes a different view. There's more central control, and that control is done by Skills Development Scotland. And apprenticeships in Scotland are based into 3-level: foundation apprenticeships, modern apprenticeships, and graduate apprenticeships, which is what we're talking about today. Graduate apprenticeships, there's 12 approved in Scotland, and one of those is engineering, design, and manufacturing, which is what we're looking at today. How do they differ? Most of those points, the first 5 points that have come up there, are the same in England and Scotland. Apprenticeships are work-based learning. They are available for up to master's level, and they are designed programs. Apprenticeship standards have been designed in partnership with industry and higher and further education. Work-based learning, but they combine academic knowledge with on-the-job training, skills development, core skills, and work experience. Individuals who participate in programs get the same learning opportunities as those that are on traditional undergraduate degrees, and they do extend to master's level. The key difference between England and Scotland, the two key differences are the development of the standard has been centrally done by Skills Development Scotland, whereas in England the onus is very much on groups of employers, which is why there's such a proliferation of standards, much more controlled, aligned with strategic intent and national objectives in Scotland. And the final bullet, which is there about the costs of apprenticeships, employers pick up the costs of apprenticeships in England, and are allowed to use money that they've contributed to the apprenticeship levy. So funding is held by employers and is the responsibility of employers. In Scotland, it's different. The costs are fully funded by Skills Development Scotland, supported by the EU, and come under the control of universities. So there's a real difference in funding between the two countries. And the final quote there from Karen Watt, graduate apprenticeships are a very welcome addition to help improve that skills challenge in Scotland. Next slide, please, David. As part of our undergraduate scheme that we run at the UKSF, we have 24 partner universities, 3 in Scotland, and Heriot-Watt are one of those partners. And so it's great to be able to support their work in terms of the graduate development programme. I think that finishes my opening remarks. We'll move on to the specifics of the programme that's offered by Heriot-Watt.
Okay, thank you, Stuart. My name is Dr. Alan Faulkner-Jones, and I'm the Programme Director of the Bachelor of Engineering programme in Engineering, Design and Manufacture, which does have 2 streams, but we're talking about the electronic one today. Thank you, David. So, first of all, Stuart's already given an overview of graduate apprenticeships, but fundamentally, for those of you who haven't come across apprenticeships at this level before, what are they? Well, they are, as Stuart said, part of a family of apprenticeships, the foundation apprenticeships for people still at school, high school, modern apprenticeships for sort of the college level, and now the graduate or graduate level apprenticeships, as they used to be called, at university level. They're another way of working, of doing a degree, which is work-based, and it's fundamentally an integration of work, learning, assessment, and reflection, which is shaped by the employer of the apprentice. It's earn while you learn, or learn while you earn, depending on your perspective, because the individual apprentices are being paid a salary, while the fees for the programme are taken care of centrally. So there's no cost to the country. There's no cost to the company for the apprentices to undertake the programme, other than the salary, and there's no cost to the apprentice themselves. It's open to both new and existing employees of companies. There's no age limit, as there are for other apprenticeship schemes, so that you can be as young or as old as you are. Anyone can do these degrees. What it isn't, it isn't a part-time degree, and it isn't a degree light. It's not an easy way, and it is still full-time. And as we've said, these are fully funded programs. And the limitation on that is the apprentice must both live and work in Scotland during the entire degree program. Next slide, please, David. So they're part of a smaller family of the engineering programs that we run at Heriot-Watt, of which I look after. There's the 3 programs there. There's a mechanical variation of engineering, design and manufacture, the electronic one, which we're going to talk about today, and there's also an instrumentation, measurement and control. Thank you, David. And again. So how does it work? So there's these 4 major points here. It's 1 day a week on campus. So for each week, 1 day is set aside by the employer for the apprentices not to do any work for the employer. They do the work on campus. So outside the COVID time, this has been a physical day on campus with classes, but these days it's remote learning. So we still have live sessions, but we use Teams and other platforms to communicate with the students. On top of that, we do recommend 4 hours additional study each week to be allocated to the students to basically tie the 2 parts of their degree together. So the work that they're doing for work with the learning that they're doing at the university, gathering evidence, that kind of thing, as we'll cover in a minute. The second point there, point 2, there's 2 what we call core courses every year, which are wholly contained and assessed within university. So they have more traditional lectures, and in some cases there are exams at the end, but these are only a maximum of 2 courses for each year. The other courses, as we'll see, are assessed differently. Unlike a traditional undergraduate degree, these go over 3 semesters, which covers between 30 and 42 weeks of the year. So it's between between September and December, between January and March, April, between April, May and July, to get to the end of the year. So there's still the traditional breaks at Christmas, Easter and the summer, but the summer period is much smaller than a traditional undergraduate degree. It's still the same length as a traditional degree. It's still 4 years, and it's still the same award at the end. We award a Bachelor of Engineering with honours from Heriot-Watt University. Thank you, David. So how is it delivered? It's delivered in a sort of flipped class mode. So we have these 2 areas of in class and out of class, and 3 points before, during and after. So before the class, the students can get acclimated with the new material via the content. We release all the material in advance. In some cases, the entire course worth of materials is released at the beginning of each year so that they can work through it at their own pace. But it's there so the students can review it before the class, take their own notes, record any questions and problems that they find during that. And then during the class, we explore the material in depth in the places where the students have identified any problems and weaknesses, and we can sort of skim over the bits that everyone's already understood. And we have activities including peer discussion and in some cases one-to-one interactions with the lecturers. If there's individual students with specific problems, then we do it during the class. And if we go outside of class, obviously the lecturers are available outside class time as well during the week. And then after class, the students can continue their learning and understanding of the material through practical implementation in the workplace, class tests, and gathering evidence for the portfolio. Next, please, David. So assessment. So we've got 2 modes of assessment here. We've got work-based learning, which represents about 80% of the assessment for the program. So these are practical or theoretical exercises with evidence that the students gather. So these are content agreed with the employer. So ideally, these are pieces of work that you need your apprentices to do for you as employees. what we can do is we can match this with the specific material that we're teaching, and then them doing their job basically earns them credits for their degree. The other 20% is made up for those core courses, which are entirely assessed on campus, either by exams or by continuous assessment. These core courses are closer to the university taught courses. Some are exactly the same, which may include undergraduates from the standard degrees in the same cohort. The university learning core courses are taught over a single semester, whereas the work-based learning courses are taught over the entire year. Tutorial exercises are provided for both courses, so problem sets with full work solutions and tutorial sessions for the students to work through and identify problems. So in terms of evidence, so the students can submit evidence of their learning for the material that we give them at the university and their application of that learning in the workplace. So these could be technical reports, these could be videos, these could be work samples, and multiple different types of evidences are available. So for each course, what we've done is we've created what we call a course specification document, which details what the students have to do in order to construct evidence, which allows them to meet all the learning outcomes. Next slide, please, David. So this might seem a bit open if certain courses are running throughout the entire year. So what we've implemented is a quarterly review process. So to act as a focus for discussions between the apprentices, their personal tutor from the university, and the work-based mentor appointed in the workplace, we can have sort of an overview of the apprentice's performance at least 4 times a year. So the apprentices keep an up-to-date portfolio of their evidence, so they don't start falling behind or missing certain elements that they need in order to pass the year. So we have a number of obviously unavoidable paperwork to help with this process, one of which is the individual learning agreement, which helps apprentices, their employers and the university keep track of what is being learned and what experience is being gained, so that the two can be tied together in the easiest way possible. And it's also so that any gaps can be identified and certain simulated activities can be run by the university to fill any gaps. So this obviously is a discussion activity to work out what the best plan is for each individual apprentice in order to demonstrate how they're meeting the framework outcome. Because they clearly describe what specifically is required for each course. Next slide, please, David. So as I mentioned in the previous slide, there's 2 types of support. So at the university, obviously there's lectures and tutorials, practical examples. We have help to identify supporting resources if they're needed. If what we're teaching isn't quite the same as how it's being done in your particular company, then we can provide tailored support materials for that. Each apprentice obviously is producing completely individual evidence work, so they get obviously individual feedback. We can provide academic mentorship and support the individual learning and identify the areas of improvement for each individual apprentice. In terms of from the other side in the workplace, the work-based mentor provides an underpinning support for the apprentices in the workplace, manages and supports the progress of that apprentice or apprentices, and provides, in certain cases, support for the transition from work to school, or indeed from company to company, or standard employee to apprentice. The line manager can act as a coach to provide a short-term support, but the work-based mentor should be a separate individual. Obviously, in the workplace, should be first to suggest potential work-based problems to meet the evidence outcomes, and obviously take regular meetings to observe the progress and to provide feedback and discuss concerns if they exist. Next, please, David. So in terms of benefits to the industry, we're a learning organisation, and the programme is structured in that way in order for the graduate apprentices to experience what they need to pass the degree in a structured and supported way. apprentices bring in new skill sets and fresh perspectives into your organisation. There's an improved quality of service. You're obviously supporting your existing employees in their further professional development. So therefore that leads to a retention of the apprentices, and it also allows help for existing employees to enhance their skills. Next please, David. So specifically on the degree then in engineering, design and manufacture electronic, why Heriot-Watt, some might ask. Well, we've got a very strong heritage in engineering and engineering related education. We were the world's first mechanics institute, founded in 1821 to provide technical education to the working classes. So this really hits to the roots of what the university was set up to do right back at day one. In terms of rankings, we're recognised for very high quality engineering programs in multiple subjects, but specifically in electronic engineering, we're ranked #1 in Scotland by the Times, Sunday Times Good University Guide, and #2 in Scotland by the 2021 Guardian University Guide. The programme itself is provisionally accredited by the Institute of Engineering Technology, which fully meets, in the term of the Bachelor of Engineering programme, fully meets the requirements for incorporated engineering status, and it partially meets the requirements of chartered engineering. So there's a little bit more work needed for that, but it's more than the IEng alone. Next please, David. So the programme itself aims to produce a Bachelor of Engineering Honours graduate who has a sound basis in theoretical engineering principles and methods, as well as their application in the context of design and analysis. They are able to operate in a team as well as in multidisciplinary contexts. They have an appreciation of the wider societal and commercial influences on and the impact of engineering. They'll have problem-solving skills and the ability to apply skills by developing innovative solutions to society's practical needs. They have developed personal qualities and professional competencies of electronic engineers, and they will be obviously tailored and contextualized to the specific needs of your company and the role that you need them to undertake. I'll now pass you on to Dr. Adnan Ilyas, who more closely runs the electronic stream of the programme.
Thank you, Alan. Good afternoon, everybody. As Alan said, my name is Adnan Ilyas. I'm one of the assistant professors on electrical and electronic engineering. So I'm going to briefly the sort of program structure and talk about some of the courses that we deliver as part of this EDM electronic degree that we offer to the GAs. So if we look at year one, so this is mostly a common year between the two streams Alan had talked about. So we do have mechanical and electronic streams. So we do very similar courses in year one. So we've got two taught courses, Maths 1 and Maths 2. These are generally meant to be delivered in semester 1 and semester 2, but due to the sort of disruptions with COVID-19 pandemic, they've sort of moved across to semester 2 and 3. And we do offer a maths summer school for anyone who doesn't sort of meet the minimum requirements from mathematics or needs sort of additional support before they start the year. So they usually do this mathematics and work-based support, or also known as our maths summer school. So hopefully next year I'll go back to summer where it belongs, but this is the sort of structure that's happening for this year. Then we've got our all-year courses for our stage 1 of the program. So if you look at, we've got Design and Manufacture 1, Electrical Lab and Programming course. So these are classed as our skills-based courses. We've got Engineering Praxis, which covers soft skills and project. Then we have our Foundation Theory courses, so courses such as Analog and Mechanics Fundamentals, Digital Logic. They would be classed as our Foundation Theory courses. In year 2, we have 4 taught courses. We've got Maths 3, Maths 4, Operations Management and Accounting for Managers. Then we've got a design project, which predominantly covers the elements of project, where the apprentices have to design something which is focused on a concept evaluation and a design process. Then we have Embedded Systems, Circuits Analysis, that covers the sort of electrical and electronic theory. then obviously there's the option where the apprentices can select one of the courses, and now this is sort of specialized courses, so it depends on their job role, their workplace requirements, or their career aspirations that they can sort of select that course. If we move forward to the next slide, David. Thank you. So if we move across to year 3, we have semiconductor electronics and electromagnetism as our 2 core courses. These are traditional undergraduate courses, and apprentices will have interaction, some sort of interaction with our undergraduate students, and these courses also have an exam associated with them. Some of the other courses include project engineering management and engineering maths. And then we do have the systems engineering project. Now, this is a larger project than what they would have done in year 2. This is sort of double the amount of credits. Usually our courses are 15 credits each, but this is a 30 credit course. Then they have the option to pick one of the courses between electrical energy systems or signals and systems, again, depending on what specialized theme they want to follow. And on to the final year, apprentices have a choice of specialized courses once again. So each semester they can pick one of the courses between the choices, and all these sort of core courses have an exam associated with them. But the bulk of their final year really is their individual project, which is their dissertation, and this is worth 60 credits for that year. And we also have an employer-based activity. Now, this activity forms part of a larger sort of project, which is specified by the employer, and it basically looks at progressing an electronic design project to successful completion, and that course again is worth 30 credits. So that's a sort of quick overview of the sort of program structure. If we can move across to the next slide, I don't think we've got anything else to cover there. So that brings us to the end of the presentation. So I'm going to hand you back to David.
Thanks, Adnan. Yeah, and a quick thank you to all speakers today. So thanks, Gillian, Stu, Alan and Adnan. So this is really, we've got some time now really to ask some questions. So I'd encourage MD to just ask a wee question.
Could I ask a question, please? It's Lynn here. In response to Stuart's presentation, he mentioned the government industrial strategy and the 5G hubs. I don't know what your opinion is. Are these agendas going to help address the skills gap, Stuart?
Thanks, Lynn. Are they going to address the skills gap? Indirectly, they will. I mean, showing the slide was to say that technology is the future. The government, both in Scotland and in the UK, are still committed to a technology-based industrial strategy, which is going to create demand for economic demand, and therefore demand for employers to employ graduates. So in that way, it will lead to that. And technologies, I know in Scotland, the 5G is seen as a real enabler for rural communities, as well as other elements of society and business. So it was really just to make the point that these are significant national strategies linked to significant investment, which is driving up growth in the sector, technology and electronics, and therefore it creates demand for more graduates.
Of course. Thanks, Stuart.
Thanks, Sean. Thanks, Lynn. I've got a wee question from Peter. So it's what is being done to increase the numbers of women involved in engineering?
I can say a few words on that. It's not directly related to the graduate apprenticeship program, but we're doing, along with a whole lot of organisations, trying to improve the gender balance and also make electronics and technology more inclusive. Whole lot of initiatives, actively promoting it to girls, focusing on outcomes, linking to things that girls are interested in, and a whole lot of things. If you drop me your if you contact me separate to this, I can share some more with you, Peter.
Thanks, John.
in response to Gillian, I just wonder, in terms of the members sharing knowledge, is that fed back to the government to help shape strategy?
Hi Lynn. Techworks just now, and predominantly myself as part of the NMI community, are in direct communication now with BASE. Now, one of the things that have been identified, bearing in mind that I've just been with NMI for 6 months, having worked in the semiconductor industry for over 20 years, is the electronics sector within the UK, not just Scotland, is not being promoted or recognised by government the way some of the other sectors are, like automotive. So we've got an automotive council, but we don't have an electronics council. So basically we are now liaising with government, direct with government, to try to get them to recognise manufacturing more within the UK and also electronics. And I'm quite pleased to say that the first meeting, which went last week, where I did a presentation on the electronics sector in the UK, was received very, very well, and we're now doing follow-up. So I'm currently engaging with some manufacturing companies within the UK, Scotland and England to put together a bigger presentation to basically present to government within the next month or so. So yes, they are recognising that electronics and the need for basically a council and to be recognised going forward. It is going to be basically the future, and we have to retain and maintain talent within the UK within this sector.
Absolutely. Oh, that's really positive. Thanks, Gillian.
Thanks, folks. Okay, we've got a wee question coming in from Bennett. How will, I think this is for Alan and Adnan really, how will we convince employers that these graduates will be ready trained and will not require extensive work-based training?
Yeah, I can jump in on that one. Thanks, David. So I think that's the fundamental root of what makes graduate apprenticeships different to the traditional undergraduate degree programs is that, yes, you have that disconnect at the end of a traditional program where you have extensive amounts of time required to retrain in some cases, or just train your engineers, your new graduates to the way your business works. The very powerful advantage of a graduate apprentice in that way is that at the end of the 4 years, not only have they achieved everything that a normal engineering graduate would have achieved, but they've been working for your company for the last 4 years, 4 days a week, or in some cases more than 4 days a week, because you've got to factor in the university breaks. So they already know how your company works. They've already been applying each of the theories and the concepts that we've been teaching them to your workplace. So they have a more well-rounded and solid understanding of those concepts than the undergraduates can ever hope to have, in my opinion.
Just to add to that, if I may, a criticism or an observation about normal undergraduate degrees is that they don't meet the needs of employers, because his apprenticeship standard is designed by employers in conjunction with higher education. And as just explained, that for the majority of the time the apprentice is within the business learning, that then they are absolutely going to be more aligned with the business and are ready to go into job roles after they complete their apprenticeship. They'll have the knowledge and understanding, the theoretical knowledge of understanding of an undergraduate degree, coupled with the training on the job training and work-based experience. So absolutely, they've got a head start.
And what they learn as well is more specific as well. So I'm more looking after the mechanical degree, so I'm going to use that as an example, if I may. So just go with me for a second. But in mechanical engineering, you've got a division between the two sides. You've got the sort of the wet side, the fluids and the thermodynamics, and the dry side for sort of strength of materials and dynamics. And for a regular degree, an undergraduate in mechanical engineering would have to learn all 4 of those, whereas a specific engineer that you'd want in your company might not interact with fluids or temperature in that way. So there's no need for them to learn those subjects. The same in the electronics degree, you've seen there's optional courses each year to tailor the knowledge that specific undergraduate graduate apprentice learns as they go. So they're learning the specific bits of information and the techniques and the theory that you need them for their specific job role.
What, can I ask a question? When, like, I'm going to go and promote, if it's okay with yourselves, the slides that have been presented by Heriot-Watt University today, and I'm going to put a push on it to some of my member organisations in this sector. What would be the next steps? Would they contact you directly? When is the next intake of basically graduate apprentices? What semester? So that's the kind of question I'll probably get asked without them going to you, because I've got the relationship with them.
The next intake will be January.
January.
So we're running a cohort in January, which we're going to be closing applications for that the first week of December.
Right. Is there limited numbers available then?
We can go back and ask for more, so that's not an issue.
Okay, thank you, Lynn.
No problem.
And after that January intake, of course, there's next year's September intake.
Yep, okay.
And as for in terms of contact details, you can contact me direct, or there is the GA generic email address, which I'll share with you as well, Gillian.
Okay. Are you happy for me to share these slides? Is that okay?
Yeah, sure. Gillian, I thought what in a couple of days, well, we're saying maybe tomorrow, but certainly by the end of the week, we'll have the recording available, if you like, which will give you the chat as well as the slides. So, I mean, we can certainly well, you've got a copy of the slides already, but what I can do is make sure we send a copy of today's recording over to you as soon as possible, because then you hear some of the chat sitting behind the slides.
Behind it. Yes. Yeah. Thank you.
So listen, if I get any more questions just now, because if we don't, we can wrap it up there. But certainly, just from my point of view, say thanks again. We've obviously got a recording of today, and sort of Gillian and Stu, we'll be promoting this again through our own channels going forward, because we do have that window of opportunity, not a very long one, but we definitely have that window of opportunity for the January starts. And I'll make sure that I can get the recording over to you as quickly as possible, Gillian. So you can
thanks.
Do the same at your end. That'd be fantastic. So if we're happy to close it there, we're happy to close it.
Thank you.
Thanks, David.
Thanks, Gillian.
Thanks all.
Thanks,
Thanks, Stu. Thanks,
Bye.
Adnan.